Math 1314, Section IC1, Spring 2022, Tyler Junior College, Section 7.2, Polynomial Functions, Video 7, Putting it all together, Graphing a Polynomial Function. In this last video in this series for Section 7.2, we're going to do everything. And the end result we will sketch the graph by hand. Then we're going to use Desmos to verify that what we sketched was actually pretty close. All right, so let's get started. We're going to graph the function by determining the following. The function is f of x equals negative x to the fourth minus x to the third plus 12x squared. You may recognize this as one of the functions that we did in the previous video when we were finding x-intercepts and for zeros and x-intercepts for unfactored functions. We will be using the results from that. So if you didn't watch the previous video, you might want to watch it. A, how many times can the graph turn? B, what is the end behavior? C, what is the y-intercept? Now, we haven't discussed y-intercepts in these videos, but it's the same story as it's always been. I'll remind you of that in a moment. D, what are the x-intercepts? E, at which x-intercepts does the graph cross the x-axis? F, at which x-intercepts does the graph touch the x-axis? And G, sketch the graph. All right, so let's start with how many times can the graph turn? Now, we haven't seen this lately because we talked about it briefly in the first video, and we really didn't do much with it later because we weren't graphing anything, but it's time to do something with it. Just a reminder that if n equals the degree, the graph can turn at most n minus 1 times. Let's widen this text box. So all we got to do is subtract 1 from the degree. Well, what is the degree of this function, this polynomial? It's the highest power on a variable, so that would be 4. N equals 4, so at most 4 minus 1, which equals 3 turns. Now, it's not a guarantee it will turn that many times, but it cannot turn more than 3 times. All right, what is the end behavior? Well, recall that the end behavior is contingent on the leading term, and we see the leading term because this polynomial function is unfactored. The leading term is negative x to the fourth minus, and then some stuff after it that doesn't matter. And we ask ourselves 2 questions. Is the leading coefficient positive or negative? Well, the leading coefficient is 1, the leading coefficient is -1, which is less than 0. And what this means is the right end falls because the right end points down. And the degree, which is 4, is even. That means that we have equal ends. So what does this mean in terms of the end behavior? Well, if the right falls and the ends are equal, then we can conclude, therefore, the left falls and the right falls. So both ends of this graph fall. Both ends of this graph point down. We'll put our results in blue boxes so that they're easier to find later and when we put it all together. If you need more help with the end behavior, go watch the end behavior videos. All right, what is the y-intercept? Well, we haven't discussed y-intercepts lately, but keep in mind that if you are a y-intercept, you are on the y-axis, and if you're on the y-axis, the x is equal to 0. And in a function, 0 goes in to the function. So to find the y-intercept, all we have to do is evaluate f of 0. But that's real easy because all of the terms have zeros. Everything's going to 0 out. -0 to the fourth minus 0 to the third plus 12 times 0 squared. Well, we get 0, 0, and 0, and altogether it's 0. Therefore, the y-intercept is when we put 0 in, we get 0 out. Our graph will go through the origin. Now, since it goes through the origin, that's a y-intercept, but it should also show up as an x-intercept, which it will here in just a second. What are the x-intercepts? Well, as we saw previously, to find the x-intercepts, we have to solve 0 equals, or rather, either way is fine, solve the function is equal to 0. Negative x to the fourth minus x to the third plus 12x squared is equal to 0. I'm going to go ahead and rewrite the factoring moves. Negative x squared is what we factor out to get x squared plus x minus 12 in parentheses. And then we can factor the parentheses further into x plus 4 times x minus 3. Again, this is the problem we did in the previous video. So if you want to see a slower, detailed explanation of the factoring, I recommend to watch it. At this point, we put each factor equal to 0. Negative x squared is equal to 0. X plus 4 is equal to 0. 0. And x minus 3 is equal to 0. At which point we solve to get x equals 0, x equals negative 4, and x equals 3. So we'll have 3 x-intercepts, one at 0, so 0, 0, one at negative 4, 0, and one at 3, 0. Now, if you're wondering why I didn't mention anything about multiplicities yet, it's because part D did not ask. But part E asks at which x-intercepts does the graph cross the x-axis. Keep in mind that when you cross the x-axis, this is when you have an odd multiplicity. Multiplicity being the power on the factor. So we have to go back and look at each intercept and decide which ones have odd multiplicity. So let's go back up to the intercepts. And let's go ahead and list all the multiplicities. X equals 0 came from the first factor. The first factor had a power of 2. The multiplicity of the first 0 is 2. X equals negative 4 came from the second factor. The second factor had an implied power of 1. So the multiplicity of x equals negative 4 is 1. And x equals 3 came from the third factor that had an implied power of 1. The multiplicity of x equals 3 is 1. And now that we've identified the multiplicities, we can now see at the intercepts at which the graph crosses the x-axis. Those are the ones with the odd multiplicities. That would be negative 4, 0. And that would also be 3, 0. And similarly, for part F, at which x-intercepts does the graph touch the x-axis? Well, touch the x-axis means even multiplicity. And the only x-intercept with an even multiplicity was 0, 0. We got a lot of information here. We've got where it crosses the x-axis, where it touches the x-axis, where it crosses the y-axis, what the ends do, and how many times it can turn. And believe it or not, that is enough information to get a decent picture of this graph. This part G is to sketch the graph. Now, if you were to sketch this manually, and I realize it's online homework and you can just pick the correct graph, but if you were to sketch this manually, I wanted that to be a black line and a little bit thicker, please. If you want to sketch this with just the information given, here's what I would recommend. First, I would actually indicate the end behavior. The end behavior on this one is the left falls and the right falls. So what I recommend doing is drawing an arrow on the left and on the right, just pointing the general direction that they're going. That's not what I wanted. So on the left, we'll have an arrow pointing down, indicating that the left end points down. And on the right, we'll put another arrow going down, pointing that the right end goes down. Now, it's important to point out that I'm not saying these are parts of the graph. I'm just indicating the directions my graph should go. I may or may not connect them as part of the graph. Keep in mind also that we're going to turn it most 3 times. And I'll explain why this is important in just a second. Our y-intercept is at 0. That's easy. Put a dot at the origin. In fact, instead of dots, I'm going to put hearts. Okay, there's our y-intercept. It's also an x-intercept. Speaking of x-intercepts, we have one at 3, one at negative 4, and one at 0. So we need to locate 3. Wait, what was it? 3, 1. Come on. 3, 1, 2, 3. Negative 4, 1, 2, 3, 4 to the left. And of course, 0 is in the middle. And we have an x-intercept at each of those numbers. One at 3, 1 at -4. But not only do we know that we have X-intercepts, we know it crosses at -4 and 3, but touches at 0. So the way I'm going to indicate that is I'm going to put a C above -4 and a C above 3 to indicate cross, and a T above 0 to indicate touch. Now, this doesn't look like much to go on, but it's a lot. Now I'm going to draw the graph. I'm starting from left and moving to the right. My graph starts low on the left, so I'll draw here, and I got to cross through the x-axis at -4. Piece of cake. Now, I've got to touch the x-axis at 0, which means my graph is going to have to turn around at some point. Now, where it turns around and how high it is when it turns around is beyond the scope of this course. It would require calculus. So for our purposes, we're not worried about how high it goes before it turns around and exactly where it turns around. We're just concerned with the fact that it's got to turn around. Now, as it turns around and starts heading towards the next intercept, it has to touch it but not cross. So it's going to bounce off at 0 and go back up, something like that. And now at some point, I'm going to have to turn around and cross at 3. Again, without calculus or technology, we won't know how high the graph gets before it turns around or where exactly it turns around. So since we're just sketching in behavior and intercepts, all we have to do is turn the graph around, cross through here, and we should wind up going in the correct direction according to the in behavior, which we do. If this were a handwritten test, this would give you 100% credit for the graph. Again, we don't know how high it gets before it turns around. That's a calculus question. We know how low it gets because it's got to bounce off at 0. Let's go into Desmos and see how close we were. I believe the graph is already there. It is. Not too shabby. Cross at -4, touch at 0, cross at -3, both ends are pointing down. Correct y-intercept also. Now Desmos tells us where the high and low points are. And if you notice, it gets pretty high. Let me insert joke there. Before it turns around the first time, not as high the second time. But again, that's a calculus question, and without calculus, we can't find those values. All right, so that's not too bad a job sketching this graph by hand without using technology at all. All right, we're going to take a look at one more example. This one's already going to be factored. Graph the function by determining the following. Same 7 things. This time g of x equals -1/8 times x minus 4 times x plus 2 squared. Do not let the fraction intimidate you. It will barely cause any problems. In fact, it doesn't cause any problems at all, and there's a reason why I chose it. You'll see why when we get there. All right. Let's start with how many times the graph will turn. Well, the problem with knowing how many times the graph will turn is that we need to know the degree. And the degree is kind of buried when the function is factored. So we need to expose the leading term so that we can figure out the degree. But we're going to need to expose the leading term anyway to find the end behavior. So why don't we go ahead and take this function and determine its leading term. This is a skill that was demonstrated in I believe it was the 3rd video about finding end behavior for factored functions. To find the leading term of the entire function, we take the leading term of each factor. -1/8 is considered a factor. It's its own leading term. X minus 4 is a factor. Its leading term is x. X plus 2 is a factor. Its leading term is also x, but that factor has a square on it. So all I have to do to find the leading term is to put together, multiply the leading terms of the individual factors. -1/8 x and x squared, plus a bunch of stuff afterwards, which doesn't concern me because it's only the degree that I need to know, and that comes from the leading term. We have -1/8. X times x squared is x to the 3rd. This is a 3rd degree polynomial. The degree is 3, which means we can turn at most 2 times. That says at most 2 times. It's about to say it a lot better. There we go. The degree equals 3, so it can turn at most 2 times. What is the end behavior? Well, again, in order to determine the end behavior, we need to know the leading term. And we've already figured out that this polynomial will start with -1/8 x to the third power, plus a bunch of other stuff. Now, do you remember what to look for when you're trying to find end behavior? The first thing you ask yourself is the leading coefficient positive or negative? And since the leading coefficient is positive, excuse me, it's not. Since the leading coefficient is negative, it's -1/8. This means that the right end falls, just like it did on the previous one. But we also consider the degree, and we look at the degree and we ask the question, is it odd or even? Since the degree is odd, that means we have opposite ends, meaning that one points up, one rises and one falls. Well, if we put all that together, why is that in purple? That means, one second, folks, I'm having formatting issues here. All right. So if we put it all together, this means that the right falls and the ends are opposite, so the left rises and the right falls. I think I want to go back up here and turn this one into 36-point font because it's our quote unquote answer, not, what is it doing? I don't know what's going on here with Zoom and its whiteboard editor. It's just acting all kinds of goofy. It's not even funny. There we go. Turn it most 2 times. Okay, let's put some blue boxes around the important information so that we can find it later. Come on. Okay, blue box here. Blue box here. All right. What is the Y-intercept? Well, the Y-intercept is old news. We just put 0 into the function, but this one you got to be a little careful. Because this function is factored, let me get rid of all this red stuff around it. Because this function is factored, evaluating it at 0 is not just a matter of saying, look at all the stuff that disappears. Evaluating it at 0 means proceed with caution. -1/8 times 0 minus 4. We're adding and subtracting to the 0, so it changes, times 0 plus 2 to the second power. Well, that gives us -1/8 times -4 times 2 squared, but 2 squared is 4. Negative times negative is positive. 4 times 4 is 16, and 1/8 of 16 is 2. So if you push the math forward, you end up getting 2, which means that our Y-intercept is at 2. Y-intercept, when we put in x equals 0, we get 2 for the Y. Let's put a blue box around that. Y'all can hear my phone dinging. All right. The worst part is over because the rest of it involves solving it equal to 0, and that's easy to do if it's already factored like this guy is. What are the X-intercepts? Well, to find the X-intercepts, all we have to do is solve the function equal to 0. -1/8 times x minus 4 times x plus 2 squared is equal to 0. But we solve that by setting individual factors equal to 0. Sorry, my name is over there and I can't make it disappear. There we go. All right, so we set each factor equal to 0. We set -1/8 equal to 0. But why am I doing that? Because -1/8 is not equal to 0. It doesn't have an x to solve for. It is a factor, and technically we should consider it, but it can't possibly cause the product to equal 0. However, x equals 4 can, and x plus 2 can. Solve the first one to get x equals 4. Solve the second one to get x equals -2, which means my x-intercepts are at 4, 0 and at 0, -2. Now we know we're about to ask where it crosses and touches, so let's go ahead and do that analysis now. The multiplicity when x is equal to 4 was 1 because that was the implied power on the factor x minus 4. The multiplicity when x equals -2 is 2 because that was the power that was explicitly stated on that factor. And because odd multiplicity means cross the x-axis, and even multiplicity means touch the x-axis, we already have the answers for parts E and F. At which x-intercepts does the graph cross the x-axis? At 4, 0. At which x-intercepts does the graph touch the x-axis? 0, -2. And by the way, they might all cross and they might all touch, but sometimes it's a combination of the two. All right, now we're going to put it all together and make the graph. Let's start by drawing some axes. X-axis, y-axis. And let's put all the pieces we need. First off, expect the graph to turn up to 2 times. The left rises and the right falls. Let's put some arrows to remind us of that. The left rises, the right falls. Again, I'm not necessarily going to connect these to make the graph. They're just visual reminders of where the left and the right ends point. The y-intercept is at 0, 2. 0, 2. It's right about here. And by the way, this is the reason I put the -1/8 in front of it. Because if I hadn't, then our y-intercept would have been -16, and it would have been really low. It was kind of a vertical control factor, if you will. We cross the x-axis at 4, 0, touch it. Hold up. I'm glad I caught this. One of these x-intercepts is incorrect because one of these x-intercepts isn't even on the x-axis. It's the second one. Glad I caught that. It's not 0, -2 because after all, doesn't it say right here x equals -2? So the first coordinate should have been -2. Making the output 0, that's what makes you an x-intercept. And the same thing down here, it should have been -2, 0. See, it doesn't matter how good you are. The best of us will make mistakes if we're not careful. Let's continue and finish. We cross the x-axis at 4, 0. We touch the x-axis at -2, 0. Cross the x-axis at 4, 0. I'm going to put a heart back down there. Might as well put one on the y-intercept. And we touch the x-axis at -2. Make sure I said that correctly. Cross at 4, touch at -2. And let's make a reminder that we cross at 4 by putting a C there, touch at -2 by putting a T there. And now I think I see the graph. I have to start high on the left, hit the heart with the T over it, turn around, keep going up, cross through the y-intercept, and then turn around and cross through the other x-intercept. So start high, touch this, cross through here, turn around. And again, with the exception of touching the x-axis, we don't know where the graph will actually turn around. That's a calculus issue. So just turn it around somewhere. Notice it crossed exactly twice. And behavior is correct. Y-intercept is correct. X-intercepts are correct. X-intercept behavior is correct. Everything looks good. Let's see how we did. Hello, Desmos. Ready, set. Not too shabby. I'll admit I knew what the graph looked like in advance, and I was kind of biased when I sketched it, but it came in high, touched and turned at -2 like it was supposed to, crossed through its y-intercept at 2, high point that we can't find without calculus, but it is a convenient point, and crosses through at 4, 0 and continues downward, falling on the right. All right, so as you can tell, it is possible to get a reasonable graph by hand by analyzing a polynomial function for n behavior, number of turns, y-intercept, x-intercept, and x-intercept behaviors. And I know some of you are thinking, that's cute. I'll just put it in a graphing calculator and get all my answers. And you can do that. But I told you at the beginning of this class, and I mentioned it throughout the course, that this is an exercise in problem solving, not answering what does the graph look like. Besides, there is a good feeling when you can process a function manually, sketch a graph manually, get out the technology and go, yeah, that's what I said.